Hi, my name is Jim Nunn, and I'm the CIO for Egan Company. We've been having an issue for a little while now with some GPS charging units that we have, and we're hoping to get past it with some electronics, and I'm going to show you some of the electronics right now. So essentially, the issue we've been having is, so this represents a car battery or a vehicle battery. So for, like, let's just say a backhoe. So the backhoe is connected, and it's normally connected into this unit, connected directly in from the battery of the backhoe into this GPS unit, and this GPS unit sends information about where this backhoe is at, and that works great. We're very happy with that. The only issue is during the winter, when this backhoe doesn't move a lot because most of the work is done in the summer, we have the issue of the battery going dead. And so we have two choices. We have 60 pieces of equipment right now, and there'll soon be 120 because of an acquisition we've had. The two choices are: we can maintain the batteries all winter by bringing these things in, disconnecting it from the backhoe, and then charging it occasionally during the winter. Option two is we could take these units and basically be replacing the battery every spring, because these lead acid batteries don't really like to be fully discharged. We've tried different things like solar power, but once it gets covered with snow and our equipment is spread all over the city, that doesn't work very well. So we're trying to take on a second approach. And what I'm going to want you to do here is pretend with me for a moment. So instead of connecting this GPS to it, we're going to connect another device. And here we go. This device, and this light represents the GPS, would kind of be hooked in right where this light is. It's a 12-volt light, and it's all hooked right into this battery. And on this little board here, we've got a few different components. This little tiny component here is an accelerometer, and you can see how small it is. It's about the size of my finger. And we also have a relay here, which is this little button here, which basically allows us to, from this microcontroller, turn the GPS unit, which is represented by this 12-volt light, turn it on and off. So currently we have kind of a big microcontroller in there, and we will be replacing it actually with this little tiny one. The reason why I don't have it in there right now is because this one is broken, but we will be getting more soon and replacing that. So the way this works is if the vehicle if this is in the vehicle and the vehicle moves, the light goes on. You can see that. And when the vehicle comes to a stop, the light will go off after a period of 30 minutes. And I'm not actually going to have it go for 30 minutes. It only goes for a few seconds here, because otherwise your demo would go on forever and ever. The other thing that we have in the CPU chip is we have a little timer set up so that after 25 days, it will automatically turn on the GPS unit for 30 minutes. The reason why we have it set to do that is so that we know if there's an issue with the GPS unit, because if it doesn't come on within a month, we know that the GPS unit is broke. So that's an important feature for us to have. Otherwise, the device could be broke and you wouldn't be sending up signal and you wouldn't know. So, and this accelerometer is very, very sensitive. And the light is going on right now because I actually have a timer set up in this chip, and that's the timer basically telling it that it's been 25 days. Obviously, we didn't want to wait 25 days, so I just had the timer go off after 2 minutes. And there's some complex programming inside this inside this little device. Essentially, this accelerometer measures, of course, acceleration, and gravity is of course a type of acceleration. So if you were to park this vehicle on a slope, it would the GPS, the force of gravity would be acting on it in a different way, and it would think that it's moving. So I actually had to do some programming inside there to counter effect gravity and to zero it out. So after 30 minutes, it would go back to a state that it wouldn't keep the GPS unit on permanently. So after any movement, basically the basics again with this is it's hooked up directly to the car battery, and then the GPS unit is plugged in to this unit, and it'll be either enclosed in the same box, or in its own little box. We have about $50 worth of parts here when we put this little one in, and the little accelerometer and this little tiny relay. But $50 worth of parts is a lot cheaper than having to replace the battery every spring just by labor alone, or having guys maintain the batteries throughout the spring. There's a lot of labor associated with that. So that's the gist behind it. Again, just to recap, car battery or the vehicle battery or the piece of equipment battery, and we actually have these hooked up to everything between backhoes and air compressors. So it would be hooked up directly into there, and it would run through a little relay, and then the accelerometer would tell when the thing moves. And when it moves, it'll actually send power to the GPS, and the GPS will say where it is currently located, and then the controller chip will also turn the GPS on after 25 days if it hasn't moved, so that we know that the GPS is still working and everything is okay. So that's it. Thank you for watching, and talk to you later.